Electricity. You are using it to watch this video, and electrical conductors like this copper wire are used to conduct electricity. But the caveat that these conductors have is that they come with some amount of resistance. But what's resistance, you may ask? Well, simply put, it's the obstruction faced by electrons when they move through the atoms of an electrical conductor. Similar to how water slows down when it moves through a clogged pipe. Now, you might be thinking, why don't the people in the lab coats find a solution to this and get resistance out of the whole equation? Then the energy crisis would be solved, right? Allow me to introduce you to superconductors. Superconductors give zero resistivity. But before you get all jumpy, superconductors are not perfect as well. They have to be cool below the critical temperature to reach zero resistivity. And critical temperatures are generally extremely low. But we'll talk more about it later. Now, to understand how superconductors do this magic, you must first understand a bit about the elementary particles. Elementary particles are categorized as fermions and bosons. Now remember this, fermions have a half integer spin and bosons an integer spin. Now electrons are fermions. That is why every shell of an atom has a limit of electrons that it can hold. But if they had been bosons, they could all cluster at the lowest shell to have the lowest energy state. So if you take a superconductor, cool it below its critical temperature and conduct electricity, atoms of the superconductor will get dislocated from their places and attracted to the passing electron, creating an area of denser positive charge around the electron, which attracts another electron with an opposite spin, and they form a pair of electrons named the Cooper pair, and their opposite spins interact in such a way that the Cooper pair start behaving like bosons, due to which the energy level of a Cooper pair becomes slightly lower than that of a normal electron. And because the superconductor is supercooled, the thermal energy from the atoms is not enough to bring the Cooper pair to a normal state, which would break the Cooper pair, and therefore they face zero resistance. Returning to the problem of extremely low critical temperatures, there was a breakthrough in 2020. A compound of carbon, nitrogen, and hydrogen was compressed between two diamonds to create a room temperature superconductor. Superconductors are already being used in technologically advanced machines like MRI scanners and the Large Hadron Collider, but we are still far from putting them to work in our daily surroundings. And the theory explained has its technical shortcomings. But failing is just another word for growing. That is all I have for now, and as always, keep learning.